So I'm going to show you today how we can go about solving nonlinear equations, various methods, because we're going to need to know this, how to do this for the next part, but also it's an important skill to have when you're an engineer or a scientist, because many equations you get may be nonlinear. So I show you right here some examples of various nonlinear equations, and you'll notice that these are equations that you can't readily solve usually by algebraic means. So linear equations you can tend to solve just by plugging and substituting and doing some sort of adding and subtracting and so forth. And you're familiar with how to solve linear equations. You've done this in algebra in many of your different courses. Nonlinear equations, on the other hand, look much more complex and are much more difficult to solve. So I have various examples right here that some of them you may be able to factor or whatnot, but for instance this last equation, there's no easy way that I know of to go ahead and solve for what x is that solves for this equation, and the same thing with all these other equations. Now let me just point out that these are examples with x, but of course the variable we may be looking for to solve in these equations that satisfies that equation may be other variables. It may be y, it may be g, it may be r, it doesn't matter. I'm just using x for these examples and these particular equations. So one of the first steps that I usually do, and it's not necessary to do this step, but I think it helps you when you're solving it to conceptualize what's going on, but that's to reformulate the problem and write it as such where it's f of x equals to 0. So let me show you an example where we have exponential of 2x equals x plus 6. If we just rewrite that, take everything on the right-hand side and move it here to the left-hand side, so the new equation is exponential of 2x minus x minus 6 equal to 0. And so this is just a rewriting of it, so this is a function of x, this left-hand side, equals to 0. And the reason why I do this is because it's oftentimes just easier to solve these problems when you have this type of setup, because now I know I just have to solve for x such that the whole function f of x equals 0. And it's just a simplified way to do that. You don't have to necessarily do this, but I find that it helps you when you're solving these problems to have it rewritten as such. So as I said, now what we need to do is find an x so that this f of x, in this case here the example, equals to 0. And there are various different ways that we can do that. Let's just look at the first one, and this is the guess and check method. And this is something you may be familiar with in some of your courses or may have tried this. But the idea is that here's our function, f of x equals this. What we do is we guess an x value, find out what f of x is. And so in this case, when x is 0, f of x is equal to -5. So you could just plug in x equals 0 into this equation, and you'll find out that the whole thing equals -5. So we know that x equals 0 is not the correct solution to this problem. So then I guess a new value, and I get f of x is equal to 0.39 when x is equal to 1. So we're getting closer to 0. And then I try f of x, or x equal to 2, and then f of x is 46.6. I'm getting farther away. So just looking at these values, I'm thinking that the x value is somewhere between 0 and 1, just because I'm -5 here, 0.39 here, so it's probably somewhere between 0 and 1. So I guess 0.5 value for x, and then I get an f of x value that's still off, and then I guess 0.8, and I get an f of x. It's getting a little closer, but still off. And if I keep just going forth and guessing x values until I get f of x equals 0, I might get something like this, where x is 0.71 and f of x is 0.0017. And at that point I say, well, this is good enough. This is close enough to 0 that I think that x is approximately or is equal to 0.971. And this is the thing with this type of method, is at some point we have to say, okay, our value for f of x is close enough to 0. It may not be fully 0, and we may have to go to 100 different decimal places to get this, very, very, very close, to get, the 0 out to 100 decimal places on this f of x part. But at some point we have to say good enough. And in this case, I'm just going to say, okay, that's probably good enough. X is equal to 0.971, and f of x is approximately equal to 0 or close enough to 0 that I think it's good enough. And that's the guess and check method. And you can do this with your calculator. You can do this setting it up various ways, but this is something you could do by hand. You could set this up by hand and just plug and chug into your calculator to come up with these answers. The next method is the graphical method, where we actually plot. So here I'm plotting f of x on the y-axis and then x on the x-axis, and I'm actually going to look for where f of x equals 0. And if I look here, about that point right here is where f of x equals 0. And so just doing the graphical method, I'm able to hone in and find out that f of x equals 0 about 0.97, which is pretty close to what I had on the previous slide for my guess and check method. The next method that we're going to talk about is using Excel or some other software. I'll show you how to do some of this stuff in Excel, but let me just point out that a lot of your graphing calculators can solve nonlinear equations. If you look in the manual or Google it, you can find out how to do this. You can do this type of stuff with MathCAD or Maple or other types of programs, MATLAB, but I'm just going to show you how we do it in Excel. So here I have an Excel spreadsheet, and we're going to go about solving the same problem we've worked on before. And the brilliance of Excel is that we can type in a formula and evaluate many times. So a lot of times it's faster than doing it in your calculator or whatnot. So here I've just created two columns here. I've labeled this first one x, and I have some x value 0, and then I've labeled this f of x, and then I have here a formula for it. And if you look up here, that's just the exponential of 2 times the x value, which is cell C7, minus the x value, which is C7 minus 6. And so this will evaluate f of x based off of this value here. And you see if I change it here to 1, that updates f of x. Let me just change that back to 0. So what I can do with Excel is once I have these formulas typed in, I can just go ahead and drag this down here and copy paste these, and you see here it jumps around. If I go x is 1, I get f of x is this, and I can use this to help me guess and check, sort of a guess and check, a quick guess and check using Excel. But it's going to be a lot faster because I just have to change that to 0.5 and it instantly updates that. We'll change 0.6, 0.7, 0.8, 0.9, 1. Again, and you see here that somewhere between these two values here we're going to get a 0, and that's between x equals 0.9 and 1. And let me just copy some more of these cells down here. I'm going to 0.95, not quite there, 0.96, 0.97. You see here we're getting closer, and if I want I can start playing around smaller values here. That's a little too high, 973, still a little high, 0.971, and that gives me this value here. And at this point I'll probably say that's good enough for the values that I want for finding out what x is. And so I got that value there. X is 0.971, gives me an f of x of this value. And again, if I wanted to, I could keep playing around with this number, make it more and more numbers past the decimal point to get this closer and closer to 0, but that's good enough. So that's one way we can do this in Excel, is just to set up our formulas and kind of do a guess and check type method. The other method using Excel is to go ahead and do goal seek or the solver. So let me just copy these right here. So here I have the x value and what the f of x value is, and what I'm going to do is let Excel do all the hard work and let it do all the solving of this. So I'm just going to click up here, Tools, and then Goal Seek. Right here, Tools and Goal Seek. And it pops up this window here. Now depending on which version of Excel you have, you may have to play around with it. It may be hidden in one of these menus up here. It may be under Solver. There may be a menu for Solver. It may be under the Tools. Wherever it is, you may have to play around with it to find out where Goal Seek is. You might have to Google it depending on which version of you're using, what year your Excel came out. But once you find Goal Seek, you get a menu like this. And so what it says is that it's asking me to set a cell to a certain value. In this case, I want to set cell G7, which is my f of x value right here, to a value of 0. That's what I want. I want this number right here to be 0. And what it's going to do is it's going to change this cell right here. So it'll set this cell to 0 by changing this cell right here, which is the x value, and then when I click OK, what will happen is the computer or Excel will go through and try to find out what the solution to that is. And so boom, instantly in like less than a second almost, it came up with this answer. X is 0.970825, gives me an f of x value of this, which is pretty close to 0, that I'm going to call good enough. And so this is a quick and easy way to go ahead and let Excel do the hard work of solving for x. And this is a little more refined than you see my value down here, 0.970825. So I get a lot more decimal places for this solution. And so those are two different ways that we can use Excel to go ahead and solve for our x value to solve our solution or to solve our equation. So there you have it.